Hello, hello, hello. Today we are going to deal with the law of sines. So yesterday we saw the law of cosines, and today it's the one with the sines. And so we're going to ask ourselves, how do we use the law of sines to solve those oblique triangles? And basically what's going to happen is there are some instances where you can't use the law of cosines because you don't have two sides or three sides with the angle enclosed. So we're going to be looking at those. And basically the law of sines is really nice. It's just a big proportion. And so with this, we can say that the sine of the angle divided by the side opposite that angle is equivalent to the sine of another angle by that divided by that side equals the sine of the last angle divided by that side. So we can set this up lots of different ways. You can just take pieces and then cross multiply and solve. It's just basically a big proportion. The other nice thing about this being a big proportion is you can also flip-flop it, and you could have A over side A over the sine of that angle equivalent to side B over the sine of that angle, and then the last side equivalent to sine of that angle. So again, this formula right here will work for any triangle. It does not have to be a right triangle. So let's do some example problems. Okay, so we have a triangle that says side B equals 6, the measure of angle B is 56 degrees, the measure of angle C is 42 degrees, and we want to know what side C is. So we're going to go ahead and draw this picture out. So with my triangle, no judging the triangle, we have side ABC, or triangle ABC, and then we know that angle B is 56 degrees, angle C is 42 degrees, and the side opposite of angle B is 6. So at this point, we can go ahead and we can set up that proportion because I want to find side C. Okay, and so when I set up this proportion up, we're going to have that we could have the side over the sine, or we could have the sine over the side. So I'm going to go ahead and say that C over the sine of 42 degrees is equivalent to B, the B value, which is 6, all over the sine of the angle that's opposite that one. Okay, and then this just becomes a really simple cross multiply and solve situation. So I'm going to multiply these guys and then end up dividing. So I'd have that C times, except for that's a 6, struggle. So I would have C times the sine of 56 degrees is equal to 6 times the sine of 42 degrees. And so all I'd have to do here, this is just a number, and if I'm trying to isolate C, I would divide both sides by the sine of 56. So we're going to use our calculator for this, and you're going to make sure that you are in degrees before you do anything. So mode degrees, and I would take 6 times the sine of 42, and then I'm going to take that answer and divide it by the sine of 56. And so I would get that the side C is approximately 4.84 blah blah blah. I'm just going to round to the nearest tenth or the nearest hundredth. So C is approximately 4.8. Okay, and so now we know one of those last sides. Now please don't be tempted to try to use the Pythagorean theorem here, because we don't know that this is a right triangle. So when I look here, now I want to take the same triangle, the same information, and I want to find that last side. So we have to do a little bit different here, because I also, if I don't know A and I don't know angle A, I can't use this proportion. So when I look here, I can use, however, that the angles in a triangle add up to be 180 degrees. So if you use what was given to you and you take 180 minus those two angles, 56 and 42, you can find that last angle, which is just 82 degrees. So now I can set up that proportion to solve for this side A. So I know that I would have A over the sine of that angle, so the sine of 82 is equivalent to, and you can use whatever sides you want here. I tend to use the things that are given to me, just in case I made a silly mistake and side C isn't 4.8, and also because we rounded a little bit there, I'm just going to use what's given. So I'm going to use B here and use 6 over the sine of 56. And now this is just another cross multiply and solve situation. So you're going to multiply these two things and then divide by the sine of 56. So we'd have that a times the sine of 56 equals to 6 times the sine of 82. If I plug that in my calculator, so 6 sine of 82, I'm still in degrees, I get that thing. Then I'm going to divide that answer by the sine of 56 degrees, and I would find out that a is approximately, and if I round to the nearest tenth, I would say 7.2. And that's all there is to the law of sines. There's going to be a couple special cases where we cannot get just one triangle using the law of sines, but we will deal with that tomorrow. Just know how to set up your proportion and draw that triangle. See ya!